He's already been dead and it's messed with his head. It's John's post-life crisis.
Welcome to John's Post-Life Crisis. I am your host, John Johnston, founder and manager of CornNation.com, your Nebraska Cornhusker site of being thankful for all that we have. This episode, we're talking with Dr. Uzma Samadani. Dr. Samadani is a brain injury researcher and neurosurgeon from Minneapolis. And we're going to be talking about CTE and, well, brains. That's what we're going to be talking about. So let's start with that. Can you, Dr. Samadani, can you give us a kind of a base definition of CTE just so we start from the scratch and we start from ground zero?
Yes, absolutely. My pleasure. Thanks for inviting me to be on your show, and I'm happy to be here. So basically, CTE stands for chronic traumatic encephalopathy. And the way that the NIH, which is sort of the people who fund a lot of research in the United States, have defined it is it's a pathologic diagnosis, which means it's something that you see underneath a microscope when you look at, sections of brain from someone basically who's dead. You don't usually take brain out of people who are living. And what they've defined it as is the presence of abnormal proteins in places where they're not supposed to be, sort of in locations where it's not normal to find them. And the protein that's abnormal is phosphorylated tau. So tau is a protein that's normally present, but it's in other locations, and it's part of the structural organization of the brain. And what has happened is it's become phosphorylated, and it's curled up, and it's clumped, and it's in the wrong places. And that is the definition of CTE as purported by the federal government. So now what people are usually talking about when they say the words CTE, usually what they mean is the global chronic effects of neurotrauma. They're referring to people who are living with consequences of brain injury that are generally due to a multiple number of different problems in their brain. And, to simplify it into one sort of problem is probably simplistic. The brain is much more complicated than most people realize, and there are so many different things that can go wrong. And so to attribute it all to one protein that's clumped in the wrong place is probably simplistic. Is that a good start, John?
It is. When you define it like that, it doesn't really sound very scary, but I have no idea. You know what I mean? Yes, it's a good definition, but you might as well have been saying blah, 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 blah to an ignorant person. You know what I mean? Their proteins clumped in the wrong area. That doesn't sound horrible at all, but obviously the effects are.
Yeah. So let me clarify a little further then. When I say what people are talking about, when you hear the letters CTE, you probably think of the chronic effects of neurotrauma, or in other words, you think of the consequences of brain injury for any one person. You think of perhaps, a football player or some other athlete who's had a long history of exposure to blows to the head, and you're thinking about, his pattern of behavior or her pattern of behavior, or his particular affective disorders, which affective disorders just mean things like, your inability to control your emotions. You're happy when you shouldn't be, you're sad when you shouldn't be, you have maybe profound depression or irritability, a lack of ability to control how you feel. That's what people think of when they think of CTE. But what that actually is the chronic effect of neurotrauma, which means it is a syndrome that consists of multiple different etiologies that, has many different reasons for existing, and is not necessarily attributable to a single problem, such as clumping of, one abnormal type of protein in the brain. It's more likely attributable to multiple different problems. And, I can give you examples. So there are about at least 12 genes that are associated with chronic effects of neurotrauma. Some of those genes have short-term impact. So if you have a brain injury, you have a slower recovery because maybe you don't turn over neurotransmitters as quickly. Or you may have a normal recovery from the immediate brain injury, but be more likely to have dementia down the road because you have an abnormal receptor for a different protein in your brain somewhere else. So we know that there are at least 12 different genes that impact recovery from brain injury. And not all of those result in the pathology known as CTE. I think of them collectively as the chronic effects of neurotrauma. So the things that play a role are genetics and environment. It's the nature of the injury. I think of brain injury in my mind as a salad. And the salad has multiple different ingredients. And some of the ingredients are things like, stretched or torn neurons. Other ingredients are, when you have bleeding in your brain, the blood breaks down and it leaves behind iron. And the iron is toxic to the neurons. And so that's another ingredient in the salad. And so you've got all of these different types of brain injury that can be happening simultaneously in the same person. And they're all leading to chronic effects. And, some of the chronic effects are worse than others. And in some people, they're worse than others. So it's a much, much more complicated problem than what would be suggested, if it were just a single protein clumping in a particular location. So I would say that the chronic effects of neurotrauma are much more complicated than most people realize because there are so many different things that can go wrong.
In the public sphere, especially when it comes to football, and I write about football, this has been really, you're talking about the complexities of this. This has kind of been dumbed down, and I hate to say, quote, the media, end quote, down to you banged your head too many times, and it isn't even about concussions. It's about the fact that you had subconcussion hits to your head, and football is bad, and sports are bad, and it really has nothing to do with genes or, iron, you know what I mean? It's become this thing that is CTE in football. And what you're saying is this, A, it's way more complex than that. B, I guess the question that's coming out of that is, has further research determined who is more likely to have CTE as a neurodegenerative disease? Is that the right term?
Yeah. So basically, I think what we have to do is we sort of have to take a step back and put this all in perspective. And the first thing we have to realize is that the vast majority of people who have a brain injury in the United States and in the world do not get their brain injuries from sports. The number one cause of brain injury in the United States right now in 5 states is falls. And it's falls in the elderly. And that generally is due to deconditioning as people age. The number 2 cause generally is car accidents. And then other accidents would be number 3. So things falling on the head. Most people who have a brain injury sustain it in an unanticipated way. So they're not doing sports that have a high risk for head impacts, but they're doing something at home, like, taking a book off a shelf or something like that, and something falls and hits them on the head. So brain injury shouldn't be thought of as a sports problem. Brain injury should really be thought of as a societal problem. So that's the first thing that I want to say. And there are a lot of problems with how we study brain injury because, the majority of National Institutes of Health funding and Department of Defense funding goes to study brain injury in athletes. The largest funded studies in the United States are the NCAA DoD CARES Consortium, which studies brain injury in young college athletes. Young college athletes represent the fittest 1% of our society. So they're not representative of the average person who gets brain injury. And what we learn from them is incredibly valuable. It's a laboratory for the rest of the world to understand brain injury, but it's not representative of brain injury in the general population. So that would be the first thing I would say. Now, the problem with football is football has become the inadvertent poster child for brain injury. When someone puts an article about brain injury in any, newspaper, magazine, whatever, they always show a picture of a football player as if to say, football is the number one cause of brain injury. And, this is where people get brain injuries. And, the reality is that the vast majority of people do not get their brain injuries playing football. And football does not result in a large number of brain injuries for most people. What we need to understand and what we need to keep in perspective is that there have been a number of very sound epidemiologic studies that have shown that playing sports in general is better for your health than not playing sports. And we're talking about studies that look at long-term outcomes. So there was a paper that was recently published. And for those of you who are on Twitter, it's on my Twitter feed. I'm at Dr. Samadani, DrSamadani. And in this paper that was recently published, they showed that NFL players who played for up to 10 years at the professional level outlived their peers. So in other words, they lived longer than their peers who did not play professional football. There have been other studies that have shown that at the high school and at the college level, children who play sports are less likely to be depressed. They're less likely to have other social disorders, complex psychosocial disorders, and they're less likely to commit suicide than their peers who do not play sports. Now, that holds true even for football. So in other words, the depression rates and the suicide rates are lower for children and young adults who play football than for people who don't play football. And we've sort of lost sight of that because as a research community, it's sort of the brain injury community in general, we've started to get an understanding of brain injury and its consequences. And that has been very, very valuable for us. But we can't use that to say, oh, hey, sports are bad, because we haven't measured the risk-benefit profile of sports. And that's the fundamental problem, is that it's wrong to condemn a sport without understanding the risk-benefit. And it's, in my opinion, it is extremely likely that if we could quantitate objectively risk-benefit for something like football, we would be able to concretely say, yes, the benefit of playing sports, and this particular sport outweighs the risk for most children. And, as you know, my son played football in high school, and in his particular case, it was exactly that. I weighed the risk-benefit for him in particular. He's an asthmatic. He had a poor lung capacity, so he couldn't run very well. And he found his niche in sports, in football in particular. He couldn't play soccer. He couldn't do cross country. Those were his other fall options. He loved football. From a psychological perspective, it really changed him. He's unfortunately had very nerdy parents on both his mother's and his father's side. And so he had a predisposition to having a very introverted personality. And football completely changed that. He was able to develop normal relationships with other children despite his innate nerdiness, and that was incredibly beneficial for him. And, my son is one kid. I saw this in all of the other children who played football with him, and I've seen it, societally when I go places and I talk to people who've played sports. Kids who play sports tend to be better adjusted than kids who don't. Sorry.
I thought you were going to go with he had nerdy parents, therefore he had no athletic ability whatsoever, which is what my kids got from me. My wife is much more athletic than I am, but they got nothing from me on the athlete side. But they got the ability to poke themselves in the eye with a pencil.
Yeah, well, he did get that as well. So you're right. Unfortunately, I was not a star athlete. But, to me, that's the advantage of football also, is that it is a sport that can be attractive to children of different talents. And, not every child has the physiology to be a cross-country runner or a tennis player or a soccer player. But many of those children, the children with larger BMIs, for example, the larger body habitus, they will find an opportunity to get active in football, and that can be life-changing. I mean, my son had a colleague on his team who was by absolutely there was no possible measure that could come up with anything less than morbidly obese for him. He was a very, very large child. And he learned they literally pulled him off the couch and made him try out for football. And this kid got in such phenomenal shape that he actually started playing other sports. And his parents said it transformed him. It made him into such a different person because he was able to find friendships and develop physical capacity through football. And so I think football can be transformative for the appropriate child.
So CTE, along with other neurodegenerative diseases, Parkinson's, Alzheimer's, I'm sure there's many of them.
Yeah.
I mean, they're terrifying. I mean, my own brain injury, I know that, by the way, in the interest of full disclosure, Dr. Samadani was my neurosurgeon when I went to the traumatic brain injury clinic at Hennepin County Medical Center in Minneapolis after my heart attack. The first question I asked you was, am I going to get Alzheimer's? And your first response was, that's the first question everybody asks you after they've had a brain injury.
Yes.
But the fear of the unknown there it's overwhelming at times. It's overwhelming me right now.
Yeah.
But, the idea that someday my wife is going to have to take care of a blubbering, drooling, idiot that can't fend for himself or watch that decay.
Yeah.
I'm not sure if there's a question there, but that has to be why most parents look at sports like football or look at their children and say, I never want them to have to deal with that. Just like I never want my wife to have to deal with that with me. I mean, How do you respond to that fear, that strong fear of the unknown, I guess?
Yeah, and this is a fabulous question. And like I said, I do get asked this a lot. My typical response to most parents when they say to me, will my child who just had a brain injury end up with dementia? I will say to them that, there are known risk factors for dementia, and they are hypertensity, high blood pressure, obesity, diabetes, smoking, social isolation, being hard of hearing. We have known risk factors for dementia. Certain medications increase your risk. Physostigmine increases your risk. Those will increase your risk for dementia. You got to realize 2/3 of people who have dementia in the United States are women who never played contact sports. So the single greatest risk factor for having dementia is gender or sex. That's independent of a history of contact sports. Playing sports does not increase your risk for neurodegenerative conditions in general, not at the high school level, not at the college level. At the NFL level, there may be some risk associated with particular positions. So the risk-benefit profile changes the higher up you get. What we also know is that children who played sports at high school level are more likely to be active at age 35 and at age 55. They're less likely to have neurodegenerative conditions later on in life. So it's really a matter of risk-benefit. When you talk about the chronic effects of neurotrauma, it's real. There's a higher risk for depression in people who have brain injury. There's a higher risk for pension disability in the largest epidemiologic study. There's a higher risk for suicidality. Even 6 years after a brain injury, there's a higher risk for suicidality. But what that doesn't mean that a child who plays sports and has a concussion has a higher risk for committing suicide than a child who didn't play sports and didn't have a concussion. It's a matter of risk benefit unique to each child. And so it's you'd have to look at the math and the numbers, but it's complicated to explain. But generally speaking, for most children, the risk of injury is almost the same whether they play sports or not. And so you have to be attentive to the type of sport that they're playing and, the nature of the child. So, we talked about genetics already, but there are genes that predispose to risk-taking behaviors. There are genes that are more likely in people who are mountain climbers. I don't know if you guys have seen these movies about the people who do free solo climbing. There's one of them's named Chin. I forget the other guy's name, but they climb up these mountains like, in Yosemite and, without ropes. And if you do genetic analyses of these people, and functional MRI, they've conditioned themselves to have no fear. So genetics has a huge impact in risk-taking behaviors, and that impacts brain injury, and it also impacts recovery from brain injury. I digress a little bit, but fundamentally, yes, brain injury definitely has risks. Your type of brain injury, the type you had, which is from a heart attack, is actually one of the types of brain injuries from which it's hardest to recover because the brain was deprived of oxygen, and that is one of the worst types of ingredients in the salad. If
that's not comforting.
Well, it's reality. But you're doing all the right things. One of the most important things to do after you have an injury like that is to get back out and exercise. And the fact that you're walking 4 miles a day and you're mountain biking again, that's going to bode well for you in the future. You're going to do better because of that. There's a guy named John Leddy at the University of Buffalo who's written an entire, career's worth of papers on how exercise helps you recover from brain injury. And, his stuff is phenomenal. I mean, he's got really concrete data showing that you improve the regulation of blood flow through the blood vessels in your brain by exercising, gradually in an increased fashion after a brain injury. It's not just hocus pocus stuff. It's really concrete science. So I think that there's a lot of evidence there. And, we know that neurotransmitters turn over better after you exercise, and having that happen as you age is far better for you. So I think you're doing the right things.
Okay, well, can we talk about concussions for a bit?
Yes, absolutely.
It seems to me that from a layperson perspective, in other words, a person like me who is not a healthcare professional, who does not have any healthcare background, that we seem to think that there's a clear-cut definition of what a concussion is. That's not exactly true, is it?
You are absolutely correct. There are more than 40 different medical and sporting organizations that have defined concussion, and not all the definitions are exactly the same. So if you go by, for example, there's this large sporting group that consists of members of FIFA and the NFL and NCAA and, many different sporting organizations. And they meet every 4 years, and their last Congress, I think it was in Berlin in 2016. So they were due to meet in 2020, but they didn't. When they last met, they defined concussion as symptoms resulting from a blow to the head. And the problem with that definition is that you may not necessarily have a brain injury, even if you have symptoms resulting from a blow to the head, because you may have injured your neck, you may have an inner ear problem, you may have a vasovagal problem, you may have other problems that cause similar symptoms as a brain injury, but not actually have a brain injury. And so that's their definition of concussion. And that's a widely used definition, but it's not necessarily the definition that, say, I in my laboratory use, because I use physiologic dysfunction of the brain that's radiographically occult as my definition of concussion. It all depends on how you define it. So for most people on the street, we think of concussion as something that happens after you get hit in the head. And that's pretty much the definition that many sporting organizations are using. But it's not necessarily a consistent definition across medicine.
So you've done research into concussions.
Yes.
Can you tell us about that?
All of my research focuses on objective measures, which means things that you can measure that you don't just sort of make up, for brain injury. And my lab has focused, I'm in bioinformatics and computational biology at the University of Minnesota, and I collaborate with a bunch of computer scientists. A Dr. Roy Kwang and a Dr. Yuk Sham are two of my collaborators. And what we're doing is we are looking at objective ways to measure brain injury using things that don't depend on how you feel. So the measures that we use in our research are radiographic measures like CT and MRI. We use serum markers such as GFAP and UCHL1, and we use eye tracking. So eye tracking is something that I've been working on since about 2011. We have spun out a company out of our lab. The company's called Oculogica. Oculogica was able to get FDA marketing authorization for aid in the diagnosis of concussion in 2018, and we are commercially available now. Then that is a financial disclosure that I have. But ultimately, the hope is that by combining these objective measures, you can figure out what the ingredients in the salad are. You can figure out what the nature of brain injury is. You can figure out which pathologies are affecting somebody so that you can understand how to treat it. And we're not obviously the only people working on this. There are a number of laboratories all over the country that work on brain injury. I'm part of a larger research group called Track TBI. They've recruited 3,000 patients at 13 different hospitals across the country to understand brain injury better. I know a number of people in the field who have made significant progress, not looking only at these three measures that our lab focuses on, but also at other measures.
When you again, from a layperson, well, that's all I am. That's redundant.
Yeah.
When you look at the public sphere and the CTE issues and the concussion issues,
yeah,
it's almost as if we're told this science is settled already.
Yeah.
And if you bang your head too many times too hard, you're going to have problems, and that's the end of it.
Yeah. It's pretty complicated. I mean, I would say that we're in our infancy in terms of understanding brain injury. We are where heart disease was in 1950. So if like the heart is a great example because, it's so easy to measure function, right? It's a pump. You measure what comes in, you measure what comes out, you get an ejection fraction, you know how well the heart works, done. And to measure electrical activity across the heart, there's an objective measure. You get an EKG, you can measure the electricity, right? The brain doesn't have that. We don't have a measure for function that tells you how well your brain is working. And why is that? It's because everyone's brain is so incredibly unique. From the moment they're born, people have different capacity. And, things change over time. So if you're exposed to certain things, it changes your brain in ways that will impact long-term function. And so we don't have these clear objective measures for function that, the other organs have in the body. And that makes it a lot harder. That makes it harder for coaches to figure out when someone can return to play. It makes it harder for employers to know when a person who's injured on the job can come back to work. It makes it harder for doctors to take care of patients who say there's something wrong, but no one can measure it. And so that's why we need objective measures. Okay.
I was going to say that when I started reading about this, there was this period of time between my heart attack and that I finally got diagnosed with a TBI.
Yeah.
And I started reading as many books as I could. I'm not going to become a neurologist, obviously. I don't have that capacity. But it seems to me that brains research is much more contentious than it's portrayed publicly. And there are people that would say that you're a horrible parent for letting your child play football.
Oh, yeah.
And some of those people would be brain researchers.
Yeah. Well, I haven't actually no person who works on brain injury who that I understand has ever said to me, why would you let your child play football? Because they understand the data just as well as I do. And many of them have children who play competitive sports. In fact, I would say, on the contrary, it's people who don't understand brain injury who are more likely to be concerned because they don't understand the risk-benefit threshold anywhere near as well as people who do. I'm at an advantage over the vast majority of parents because I would have better capacity to care for my child if he were to have a brain injury, God forbid. So ultimately, I think to get back to your question, how do we understand this from a societal perspective? I think that we have to allow children to develop themselves, physically and socially. And sports are probably the best way to do that. And, the risk of brain injury is very real, but we have to minimize it by, number one, acknowledging it, taking care of it. And number two, developing objective measures for it. Now, getting back to what you were saying about, is this controversial? I think what's happened in medicine in general is a lot of people they have their financial priorities. And so, for example, there was a movie that was made by Steve Devick, who markets the King Devick test for concussion. And he called it Brain Games or something like this. And essentially what he argued was that sports are incredibly dangerous. And, when you watch that movie, anyone who watches that movie would immediately think, I should never let my child play sports. But you got to realize this movie was made by a guy who's trying to market a concussion test direct to consumers, not a medical test, not something that's cleared by the FDA, but something that's going direct to consumers. And I think that, he has an ulterior motive. And there are a number of other organizations that have those motives. The people who've simplified the chronic effects of neurotrauma and turned it into sort of this thing called CTE, that they've made complex pathophysiology into one pathology. What they're trying to then do is say, this is one pathology, we can detect it and we can treat it. And yet it's not even true. It's not even responsible for the vast majority of cases, at least not as far as we know. So they have a profit motive, and that's a problem. It's a fundamentally, to me, that's a big problem. And I've been called worse than I've been called an NFL shill. I've been called, a parent who doesn't care about my child. Neither of those is true. I've been called worse. I don't know what to say,
I think it's interesting how they, from a regular person perspective, how dumbed down all of this is. Go back to CTE for a second. Is there any way to determine if somebody has that before they're dead, or is that any closer to happening?
Well, I think it depends on what you consider as CTE. If you're talking about deposition of tau in sulci of the brain where it's not supposed to be, this protein accumulating in abnormal places, yes, you could probably determine it with a PET scan looking for tau. There are certain types of imaging that can be helpful. What does that mean? I don't know. You have to realize that we don't understand the implications of tau because we don't know if it's causative or just associative with the chronic effects of neurotrauma. And, I'm on a study section, I'm on a grant panel, and one of the studies was they were going to accumulate tau protein in mice and treat it. And, that's great and all, but it's making the exact same mistake that the Alzheimer's field made when they accumulated amyloid and treated it. And they spent literally billions of dollars and it didn't treat dementia one single bit. Every single study, 20 studies have failed. It's about $20 billion down the drain. Multiple companies have gone bankrupt trying to pursue treatment of amyloid deposition for dementia. And now the brain injury community sort of is kind of doing the same thing where we're treating tau for chronic effects of neurotrauma when we have no idea if it's causative. So, when you ask, is it possible to diagnose CTE in living people? I would say, if it is possible, is it useful? I think what would be much more useful is to understand through objective measures both the acute and chronic effects of neurotrauma globally, understand the pathophysiology completely, and then treat it.
Oh my God. This is so much to absorb.
Sorry, I hope that, I tend to condense things a lot. I don't know.
I have to take a breath. Okay. I'm going to ask you hopefully one more question. Well, a couple more questions.
Yes.
let's pull this. We're currently in a pandemic,
Yeah.
and the world's turned upside down.
Yeah.
And then we have this CTE, which, earlier I talked about the fact that having dementia or any kind of neurodegenerative disease is terrifying.
Yeah.
At the same time, we seem to live now in the United States, particularly in a culture that is constantly worried about safety.
Yeah.
Everything is geared toward everyone must be safe and everything must be safe. And everywhere I go, I need to feel safe. What is this? This seems to me to be a setup to make everybody have more anxiety than ever, and it ignores the fact that there's an inherent risk in life. You remember Dr. Cole?
Yeah.
Okay, last winter I was asked him if it was okay for me to go jump participate in a polar challenge where I jumped in a frozen lake.
Yeah.
And he said, well, it's not any different than if you were frightened suddenly or if you're in a car accident or, something else happened to you immediately that would shoot your heart rate up. So I don't see any problem with it. And he used the phrase that stuck with me, inherent risk in life, which there is. Every time I get up, every time I walk outside, there's an inherent risk there. And that seems to be completely thrown by the wayside with the word safe. Can you talk about that for a bit or discuss that?
Sure. Well, with regards to brain injury, I feel like it's mostly misperception. I think that the risk-benefit profile of sports is such that benefit outweighs the risk. So I think what it is a lack of understanding of risk-benefit, not only by the public, but by the scientific community, which, has not spoken up enough about the fact that playing sports is probably more beneficial than not playing sports. With regards to COVID, I actually think it's a different problem completely. COVID was a virus that was, present in limited numbers early on. And had there been more definitive efforts to sort of restrict its spread, contain it, I think we would have done much better. And even now, if everybody just wore an N95 mask for 3 weeks, it would disappear because there would be no transmission and it would have no place to go. And that's how other democracies have succeeded in eliminating it. If you don't transmit it, then it's not going to be a problem. I think COVID is very different because, brain injury does impact your immediate circle, but it's not communicable to other people in the sense that a virus is. And so the problem with a virus is that, it's not the football player getting it from another teammate that might be the problem, although that could pose a problem. It's more that they bring it home to their parents and their grandparents and their teachers, and those people might be at increased risk. So I think that it would have been relatively straightforward if everybody had just agreed, early on, okay, everyone wears a mask for the next 3 weeks, and then we would have been done with it. That just never happened. And so I think it's a different problem. Going back to your idea of there's inherent risk in many things, I think there is, but we also have to accept that science can help us. And, science has helped us to understand the chronic effects of neurotrauma, but it's also created this huge and unmitigated irrational fear about sports. And here, science has helped us understand that, viruses exist and we need to take measures to treat them. But we as a society have not taken those measures. And therefore, we're dealing with the consequences.
What you said that earlier, that right now brain research is like heart research back in 1950.
Yeah.
How many years? Obviously, this is going to be researched for until the end of humanity.
Right.
I guess when I read this stuff, it's so complex that I don't see how anybody can really figure it out in the next 2 decades. But
right.
Put yourself 10 years from now. What advances do you see in the area, not just CTE, but neurodegenerative diseases? What are there any breakthroughs that are on the horizon to help with that stuff?
I hope so. I think it requires a lot of fundamental changes in how we organize healthcare in our society, because right now, brain injury is not what you call reimbursed well, which means that there's no motivation for hospitals to set up clinics to treat people with brain injury. Because, so let's compare it to orthopedics, right? So a guy has a trauma, right? And suppose he breaks his leg. He goes in, he gets an x-ray. The orthopod looks at the x-ray. They said, broken, fix, 2 words, right? They take the guy to the operating room, they put in their whatever rod or whatever, and then they fix it, right? And then they get another x-ray, it looks good, they send the guy home, right? They can bill for that because there's an x-ray that shows that it's broken. Now imagine the same guy comes in with a brain injury, right? And he hits his head and the CT is negative, it's normal, and nobody sees anything. And the guy goes home and he's like, well, I'm almost okay, but I'm not really okay. And he can't do his job, and all of a sudden he's unemployed, and then he's, getting a divorce from his significant other, and, he's destroying his social contacts, and he becomes an alcoholic, and then he becomes homeless, and he goes into the death spiral. And why? Because there's no objective measure, and there's nothing that the hospital can bill for and say, hey, this was broken, and we fixed it. And until that changes, we're not going to be able to treat brain injury. We have to have objective measures so that hospitals and clinics can bill for them so that we have an incentive to make these people better. And when brain injury gets the same respect as a broken bone in someone's leg, then we're going to have progress.
I think there is a... Sorry.
It's okay.
Talking about myself is always still hard.
Yeah.
There is a chapter in my book that is called, it discusses that brain injuries are invisible.
Yeah.
At one point when I was going through speech pathology therapy, I had that realization that when I'm walking around in my job and I was trying to recover and I was trying to work with people again, I realized that if I had a broken leg, then it would be an outward sign that I had something wrong with me. If I had a broken arm, I had my arm in a cast.
Yep.
It would be indicative. People would help me. They'd go, oh, let me open the door. Oh, let me carry that for you.
Yep.
But the brain injury part of me was invisible to people.
Yep.
Early on, I found myself saying, yeah, I have a brain injury, which was really, honestly, in the long term, I discovered it really wasn't the best approach because they got this look, people got this look on their face like, oh my God, he's going to be a serial killer or something. You know what I mean? But, a lot of them, the reactions were really different. They just kind of like, what the hell am I dealing with here? Who is this guy that has a brain injury, yet he's talking to me? Because I don't know what they thought, but yeah, I get where you're going. And basically the other part of that chapter has to deal with the idea that no doctor can tell you where you're going, really.
Yeah.
If you're the patient that has a brain injury, it's kind of up to you to determine, how you're feeling, communicating with your doctors honestly, because I'll tell you what, as a 58-year-old guy now, it's easy to lie to doctors all the time. Like, how much are you drinking? Oh, a 6-pack a week. Well, okay, maybe it's 2 cases. You know what I mean?
Yeah.
It's easy to look at them and go, hey, how are you feeling? Well, you're depressed as hell, and you say you feel fine. Because that's what we do,
Yeah.
I don't know if there's really a question here, but I guess my own experience with it is, it's incredibly invisible. How are you going to ever be able to measure something like that? There's not a measurement we can't even define what human consciousness is.
Yeah. No,
how are you going to measure that?
Objective measures for neurologic function, for mental health, for happiness, for pain, for all of these things. That's what my lab is working on. Where, eye tracking will go a long way towards giving visibility to brain injury. Because, if your eyes aren't working, that means there's something wrong. 40% of the brain is involved in control of eye movements, so that will help. Serum markers will also help, and algorithmic radiographic measures will also help. There is hope. I think that there's going to be significant progress. It's a matter of changing the structures so that we treat mental health and neurologic health as significantly as we treat, your kidneys, your heart, your bones, things that we can easily see and easily measure function on.
This was a lot to absorb. I do have one more question, and it's a personal question. You have to, between the time I've seen you and now,
yeah,
you have to have seen hundreds of patients.
Yes.
How the hell do you remember who I am?
Well, number one, I see relatively few patients who don't need surgery. So that actually was one thing that I remembered about you. And you were very patient with me. I remember I was in a huge hurry when I saw you because I had a trauma that I was dealing with. But I remembered that about you. And then the other thing was the football connection. So you had mentioned some connection to football, and hardly anyone comes in my office with a football related problem. So I know your problem wasn't related to football directly, but you're active in that community. And so that's why I remembered you. But I used to have, when I was a resident in neurosurgery residency, I had a photographic memory. And I think all these years of taking call have made it worse. I still have a pretty decent memory, but it's not what it used to be. But, you sort of stood out. That's why I remembered you.
I thought you were going to say I had a beautiful smile. I'll tell you this story, and it's in the book also, but I did meet with, I think it was a pharmacologist, if that's the right term, at HCMC at one point. Mm-hmm. And she looked at me and she said, I've read your medical history. You're an amazing man. And then at the end of the appointment, she said, I'd like to see you again. And I went home and I told my wife, and she goes, how was the appointment? And I said, well, I met a beautiful woman. She told me, and I was an amazing man, and she wants to see me again. My wife did not think this was as funny as I did.
Well, understandably.
Is there anything else that we should end with that I haven't asked you that you should tell us?
No, I think, I appreciate all you're doing to help educate the public about these complex problems, because they're not simple. And so the more we can talk about them and the more we can understand them and explain them to regular people and everybody is fantastic.
Well, we're going to end there. This has been John's post-life crisis, and thank you all for listening. Go Big Red, and thank you, Dr. Uzma Samadani, for joining us.
You're welcome. My pleasure.